Hi everybody, it's good to see you again. I hope you had a great weekend. It's Monday, the 27th of April today. If you go outside, tonight we have a waxing crescent moon. So waxing, remember, means it looks like it's going to get a little bit bigger every night. And we are going to tackle the first half of our end of year math assessment today. So I'd like you to get that it's in the back of your week 5 packet. You'll find it there. And it has 22 problems, and a lot of the problems are multiple steps. So what we're going to do is today we're going to do 1 through 12 together. Remember to stop and pause the video as I go through the problems with you and complete the problems. When you're done with number 12 today, put the test somewhere safe and sound. You don't need to send me any pictures tonight because tomorrow when we finish the test, we're going to do 13 through 22 tomorrow, and then I'd like you to send me the whole test at once. That way I'm not trying to flip back and forth between 2 days to check your test, okay? 2 days of turned in work. All right, so we're going to do 1 through 12. And then we're going to talk about our language arts unit for this week. This is our last week with the Reading Wonders program. We're on unit 5, week 5. And then after tomorrow, after this week, we're going to move on into our novel study, The Lemonade War. So we'll start reading The Lemonade War and working on that together. So I'm excited, looking forward to that, and looking forward to wrapping up this week with Reading Wonders. It's been a great year with Reading Wonders. We've learned lots and lots. So let's go ahead and start the math test, all right? Okay, so if you have that out, you also need a pencil with a good eraser on it. And I'm going to use my whiteboard and go problem by problem. And then you need to make sure that when you're all done with the problem, you're ready to move on. But before that, you stop my video, pause my video, and finish one problem at a time, okay? All right, so let's read number 1 together. Ready? You should be up here. Annabelle is measuring the widths of coins from around the world. Create a line plot using her measurement data. Now we remember a line plot is when we use those X's to represent instead. It's kind of like a vertical bar graph, but we use X's instead. Do you remember what the important things are when we're making those X's to represent amounts? Right, the X's all need to be the same size, and they need to be a nice straight vertical line so they're easy for me to read. If the X's are different sizes, I can't. It's hard for the plot doesn't look accurate. Okay, and it's hard for people to read. All right, so we're measuring the widths of coins. So first of all, you need to look at. It says measures of world coins, and then here it says width in inches. So the width is from one side of the coin to the other side of the coin across the middle, okay? So this is 1/2 inch, 3/4 of an inch, 1 inch, 1 1/4 inch, 1 1/2 inches. All right, and so she measured different coins from around the world, and if you look at this tally chart, this says measures of world coins, measure, that's how many inches the width is, and number of coins that had that width. Okay, so if you look at this, if you see how many coins had 1/2 inch width, and you look at our tallies, you can count 1, 2, 3. 3 coins had a 1/2 inch width. And then you can keep reading that. So we want to fill in this line plot using the measurement data. So if there are 3 coins that had a 1/2 inch width, then you're going to put 3 same size X's in a vertical line above that 1/2. Do you remember doing that? I bet you do. Okay, so when you're done filling in this line over here, filling in the line plot, using this data, we're going to go on to the second part of the problem. Now there's another part of the problem, and it's 2 parts. So make sure you pay attention to what I'm saying now. Measure the widths of these 2 coins to the nearest 1/4 inch. So you're going to need to get out your ruler, and there's a little black arrow so you can see exactly where to measure on each coin. Measure from one side of the coin to the other to the nearest 1/4 inch. Write the measurement of that coin to the nearest 1/4 inch, and then do the same with this coin. All right, but then we're not done, and you might want to circle this. It says add the data to your line plot. So circle that, and then you want to put an X for each of these coins where they fit on this line plot. So you're going to be adding, after you finish this, you're going to be adding 2 more X's. 1 for this coin and 1 for this coin back up to the line plot, okay? Don't forget to do that. You don't want to miss points for that. All right? Then this is a fraction strip. So the big rectangle is the whole, And we can see the fraction strip is broken up into 1, 2, 3, 4, 5, 6 parts. They say label each section of the fraction strip with a unit fraction. So each section is 1 out of 6 parts. Show me how you'd label that with a fraction. Each one is 1 out of 6. All right? Okay, we're all ready to go on to number 3. Fill in the factor in the missing fact triangle. So here we go. We have a missing factor here on the fact triangle. And I can see that this is a multiplication or division fact triangle. So I'm going to ask myself, 72 divided by 8 equals what? Or I can say, what number times 8 equals 72? And then you need to show me both multiplication and both division problems for that fact family right here. And we've done that so many times. You guys are experts at that by now. All right, going on to number 4 together. When you're ready, remember to pause it, do the problem, and then when you're ready, start the video again. 5 friends win $75 in a contest. They agree to share the money equally. So we see these words shared equally. That means we're going to be dividing the $75 among 5 friends. Okay? How much money does each friend get? The letter D represents the number of dollars per friend. So they're already telling us D equals dollars. So D is the unknown. Number model with letter. So you're going to write a division number model or a missing factor number model using 75 divided by 5 friends. Write that, and D represents the unknown. They have $10 bills and $1 bills. Use numbers or pictures to show how much money each friend gets. So here's where you're going to need to draw a diagram for me. So there are 5 friends sharing $75. So I want you to draw 5 boxes. Okay, and you're going to share $75 equally. Now start with the $10 bills. So if you give everybody 10, how much money have you spent? 10, 20, 30, 40, 50. So you have $75. You've now shared 50 of the dollars by giving everybody a $10 bill. What's left? That's right, you have $25 left, and you have to share it among 5 friends. Right? So how much money does each friend get? What's 25 divided by 5? Solve that and then give each friend that amount of money. And then you'll be able to tell me how much money each friend gets. Okay? So we started with $75. We gave everybody $10, which was $50 altogether. And we had $25 left. You see how we did that already? And then down here, we have $25 left, shared equally, or divided among 5 friends. So how much does each friend get? Go ahead and put that in the box. Once you're done drawing that diagram and all the number models you need, write your answer down here and make sure you include the unit, dollars. Okay. Pause the video until you're ready to go on to number 5. Okay. I'm going to go ahead and read number 5 now. Jacob solved 6 times 7 like this. 3 plus 7, in parentheses, 3 times 7 plus 3 times 7 equals 21 plus 21 equals 42. He solved 16 times 5 like this. 8 times 5 plus, in parentheses, plus 8 times 5 in parentheses equals 40 plus 40 equals 80. What is the same about Jacob's strategy for both problems? Well, for both problems, Jacob took one of the factors and split it in what? In half. That's right. So I want you to tell me that which factors he split in half. So, and write that out as a sentence. Jacob split the factors blank and blank, one from each problem, in half. All right, that's a big clue. Show how you can use Jacob's strategy to solve 8 times 9. Now, if we're splitting factors in half, they have to be what? That's right, they have to be an even number. So we're talking about when we're in class and we do this, we call it doubling. Okay, so that's what you're using. You're using the doubling strategy, which means you're taking the even factor, you're dividing it in half, and then you're multiplying each half times the other factor. Okay? So show me those number models for 8 times 9 using doubling. All right? Write another multiplication problem that you could solve using Jacob's strategy. Well, you're going to write another multiplication problem here where one of the factors is an even number, and you can use doubling. You can break it in half to solve it. Then you're going to explain how Jacob's strategy works for your problem. Well, you're going to do the same thing that they did up here with your numbers. You just do it down there. Use those same number models they used up here for these problems. Show your problem. Make sure you have an even factor that you can divide in half. Then you're going to take the half and multiply it by the other number. Do that 2 times in parentheses. Then add your products together for the total. Do all those number models right down here. Okay? Now you're going to need a ruler so you have a nice straight line. Partition and shade the circles to show 2 halves equals 6 sixths. That means you're going to have to divide one of the circles in half, and one of the circles you're going to have to divide into sixths. And shade 2 halves and 6 sixths. Once you've shaded 2 halves and 6 sixths, explain why the circles above must be the same size. Why does the whole, that means the whole circle, why do they have to be the same size to compare these two fractions? Okay? When you're ready, we're going to move on to number 7 and talk about order of operations. Okay, here we are. We're at number 7, and it's really important that we read the directions up here first so we know that we're doing down here. So let's go back up here. It says rules for the order of operations. Number 1, do the operations inside the parentheses first. Then follow rules 2 and 3 when computing inside parentheses. When you're done with the problem inside the parentheses, if there are parentheses, you have to multiply or divide in order from left to right. Finally, add or subtract in order from left to right. So I noticed this problem doesn't have parentheses. That means I skip number 1 and go right to number 2 for this top problem. The bottom problem does have parentheses. That means I follow rule 1 first and then I go in order. Okay? Go ahead and show all your work for these two down here for part B. And also you need to explain why the 2 number sentences have different problems. Okay, and it has a lot to do with the fact that one of them has parentheses and one doesn't. That's a huge hint. All right, here we are at number 8. Eddie is planting a 6-foot by 15-foot flower garden. It might be Edie. She is planting sunflowers in one part and daisies in the other part. So this part is daisies and this part is sunflowers. Write 1 or more number models that represent how you can find the area of the garden, remembering the area is length times width. So we're going to count. What's the length? And you're going to write it down. 1, 2, 3, 4, 5, 6. The length is 6 for both daisies and sunflowers. The width of the garden that you're planting daisies in is 1, 2, 3, 4, 5. So this is a 6 by 5 rectangle. For sunflowers, we already counted 6. And then we're going to count across. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the sunflowers are a 6 by 10 rectangle. Okay? Then you're going to find the area of both of those. Right? 6 by 5 and 6 by 10. And then you're going to write the number models for that, how you found the areas of both of those. And then you're going to need to do what? Add them together, right, for the area of the entire garden. And then down here it says total area of Edie's garden is blank square feet. That's the total of both of these 2 rectangles together. So show me that those 3 number models. You're going to have to do 2 to find the area of the small rectangles and then 1 to add those products together to find the area of the entire garden. Okay, number 9. A collection of 6 movie tickets is shared equally. There's that shared equally again. That means we're dividing again. Among 3 families. So 3 families are sharing a collection of 6 movie tickets. How many tickets does each family get? So you're going to divide 6 among 3 families and tell me how many tickets each family gets. Okay? What fraction of the collection of movie tickets does each family get? Each family gets blank of the tickets. So you divided 6 among 3 families and you saw how many tickets each family got. So the numerator is the number of tickets each family got. The denominator is the total number of tickets there were that they were dividing, which was 6, okay? Now we have a fraction memory game, which we've played together. All right? During a game of fraction memory, Marta turns over these 2 cards. Okay? All right. Now this one is 1, 2, 3, 4, 5, 6. 6 is the number of parts, and it shows 5 out of 6 parts shaded. And then in this one is 1, 2, 3, 4, 5, 6, 7, 8. And so this one's divided into eighths, and it shows 7 of the 8ths parts shaded. She thinks she found a pair of equivalent fractions. Do you agree? Well, they are very similar, so look very closely. Do you agree? Is the same amount of each circle shaded or not? So you need to tell me, yes, I agree, or no, I don't, and which fraction is larger than the other if you don't agree. Okay? And why? And you can look at the number lines and the amount of each circle that's shaded. And look carefully. Don't hurry on this one or you'll get the answer wrong. Okay, part B. Use your fraction cards to find a pair of equivalent fractions. Record your 2 fractions on the lines below. So you should still have your fraction cards. I sent those home with you. If you don't, I'll post them. I'll put an attachment to the parent email and I'll post them in our Google Classroom so you can look at the different fraction cards. And you're going to need to find 2 equivalent fractions with your fraction cards and write them down. Now tell me why the fractions are equivalent, and I want you to tell me, so we know the wholes are the same size, so you need to tell me like about, are the shaded parts the same? Or are they in the same place on the number line? You tell me how you know they're equivalent, all right? Great, that's number 10, just 2 left. All right, for this part you still need your fraction cards, and you're gonna write greater than, less than, or equal to make the number sentences true. You may, we will use our fraction tools. It says you may, we will. So make sure you know that this is a greater than symbol, this is the less than symbol, and we all know the equal to symbol. And I want you to use your fraction cards to tell me if this side is greater than, less than, or equal to the other side. Okay? Then it says, what do you notice about the fractions in part A and B? Well, fraction A is 1 whole is equal to 4/4. And B is 3/3 is equal to 4/4. So what do we know about fractions when the numerator and denominator are the same? What do we know? They equal what? So tell me that on the line, okay? All right, last problem, number 12. We have 500 milliliters in this beaker. And in the smaller beaker, we have 250 milliliters. So that's beaker A and beaker B. And then let's look at beaker C. Beaker C can hold up to 1,000 milliliters, which is 1 liter. But let's see what they ask us to do. If you pour the water from beakers A and B into beaker C, will beaker C be full? So we're going to pour 500 plus 250 into this beaker. So you need to add these 2 beakers together and fill up where they'd get to on here and tell me, does it make it to 1 whole liter? Does it make it to 1,000 milliliters or not? So will beaker be full? If you yes or no. What volume of water will be in beaker C after you pour in water from beakers A and B? So you need to add these 2 together and tell me what they equal. Include the unit, milliliters. Last problem. Shade beaker C to show the total liquid volume. We just talked about doing that. I'd also like you to label it over here to the side. About how much more water would you need to fill beaker C? So if beaker C holds 1,000 liters and you've filled it up to a certain amount, how much more do you have to put in to reach 1,000? So you could use that. You could use a subtraction or a missing add-in problem to solve that. Okay? So tell me how much more you have to add and include the milliliters label. Okay? That's it for math. Not too bad. Good job. I hope you took your time. Put this somewhere safe because we're going to finish the test tomorrow. Remember, I don't need pictures tonight. I'd like all the pictures tomorrow night. So everything's in the same place for me when I check it. Okay? Awesome. Okay, this is our last week of Unit 5. I know you've seen this card for a few weeks now. Remember, the big idea for Unit 5 is, what are ways people take action? And we are on Unit 5, Week 5. And we are going to be talking about this week, what are different kinds of energy? So we're going to be reading expository texts that tell us about different types of energy people can use to power things in their home, like lights or the heater or other things. And I think we're going to be talking about renewable resources this week. That means energy sources that we can renew, that we won't run out of here on Earth eventually. And we're going to be using expository text. And we'll talk about that a little more tomorrow before we get together for our Google Hangout when we read our story, okay? I would like to go over the vocabulary cards, all 8 cards that you're going to see in your stories this week, okay? I also wanted to tell you, before we get to that since it's the beginning of the week, it's Monday. Go ahead and get your Unit 5, Week 5 Language Arts packet out of your Week 5 folder. Have your mom and dad give you the pretest for all the words in List 1. If you get them all right or you only miss one, please study List 2 this week. Otherwise, stick with List 1. When you're done, you can go on to use this page to go on and write your spelling words here. You can write them in fancy letters, like with swirlies or on them, or swirlies and curly cues on them if you want to have something fun to do it. Or you can just write them the regular way. And then down here, please write the vocabulary words and the definitions, just in regular print. And then we're also going to complete page 146. And page 146 says, fill in the missing syllable to make each spelling word complete. Then write the spelling word on the line. So you can see all the words spelled correctly in the word bank up here. Use that to help you with this. Fill in the missing syllable and then completely write the word on the line. Okay? I would like you to turn this into me when you're all done so I can check it. I will put the answer key in our Google Classroom today if you'd like to check it before you turn it in. Okay? All right, you ready for your vocabulary turn and talk? Okay, grab a partner at home like mom or dad, and let's do a turn and talk with our 8 new vocabulary words for Unit 5, Week 5. Okay, remember we're going to be talking about different kinds of energy. All right, so of course the first word has to be energy. Energy is the ability to do work. Good food gives Ron and his grandpa lots of energy to work together. So let's think. So Ron and his grandpa are doing work together, and if they eat healthy food, they'll have lots of energy to do it. They won't run out of energy or feel cranky. It also helps them think and solve problems. All right, so Ron and his grandpa ate a healthy lunch today. That gave them energy and helped them fix Ron's bike. If you think about something at your house that needs energy to work like a car, what does your car use? Probably gasoline, maybe electricity, maybe a combination. I want you to think about and talk about what gives you energy to go to school every day. What do you do that gives you energy to go to school every day? Do you have a good night's sleep? What do you have for breakfast? Go ahead and turn and talk. Use the word energy. All right, our next word, I'm a big fan of this one, natural. So let's talk about what natural means. When something is natural, it is found in nature. It means people don't make it. Cotton is a natural material that people use to make clothes. So here you can see cotton growing in a field, and this is something that we pick and turn into fabric. Cotton is natural because people don't make cotton, cotton grows. We can plant it and harvest it, but we don't make it. All right, I want you to think about some natural things you use every day. Maybe like wood. Do you have some furniture made out of wood? Or I know your pencils are made out of wood, right? Can you think of some other natural materials around your house that you use every day? Go ahead and turn and talk and use the word natural. Okay, the next word I don't like so much, it's pollution. And that happens sometimes when people are done using things. Pollution is harmful materials that make something dirty. Water pollution, such as garbage and chemicals, can harm animals. Can you think of something that causes air pollution? Now, if you look at this is a shore, and there's a lot of pollution washed up on the shore. The water gets dirty because people dumped chemicals and garbage into it. This is very dangerous for our planet. With your partner, can you make a list of some things that cause water pollution, like the kind in this picture? And you can make the list by talking. You don't have to write it down. Okay? All right. Now we're going to talk about the word produce. You see this family in front of their house? Do you see these solar panels on their roof? Let's talk about produce. To produce is to make or create something. The sun can produce enough solar power to heat this family's home. So, can you think of a word that means the same as produce? Makes. That's right. Makes and produce are the same thing. You can see the solar panels collect power, they collect energy from the sun, and they produce power for their home. And that energy is clean and safe. It's good energy. Can you think of things we produce from trees? What things do we produce when we use trees? Can you make a list using the word produce, talking to your partner? All right, this word is renewable. So if we use trees and other things, are those renewable? Let's think about what we use. If we use things that we get from the ground or take from the earth, are they renewable? Now, trees we can replant. So as long as we take enough, we're being sustainable with the trees and we just take what we need and then replant them, we can renew that resource. But let's think about other things we use. Do you know how we get oil or gasoline or coal? We take it out of the ground and eventually we'll run out. So those are not renewable resources. Let's find out what renewable means and what renewable resources are. Something that is renewable can be made again. Trees are a renewable resource because more trees can always grow. What does the word renewable mean? Trees are a renewable resource. That means that we can use them to make things and can grow more things, or because we can grow more trees, excuse me. Now we have to do that responsibly and sustainably. That means we have to be able to keep doing it, but they are renewable because we can plant more trees. Why is it important to use renewable resources instead of things that are not renewable? I want you to think about that. With your friend, can you think about some things that are renewable? Like, are library books renewable? Are trees renewable? What about oil? Is oil renewable? Go ahead and talk about those things with your partner. Renewable. Okay, our next word is replace. If you replace something, it takes the place of something that you've already had. So soon, Tina will replace her car with one that runs on electricity. Can you name something that you can replace? I'm sure you have belongings that you can replace and ones that you can't. Like maybe you have outgrown your pair of shoes, so you're going to replace them with a larger sized shoe, right? You can replace your shoes, but you probably have some things you can't replace, right? Like maybe your parents. All right, so now we're going to look at this picture that demonstrates the word replace. This woman wants to replace her car with a new one. This car uses gas. She wants a new one that uses electricity instead. Can you tell your partner when you had about a time that you had to replace something, just like the example I just gave you with the shoes? Can you think of something else you've had to replace? Why did you need to replace it? Go ahead and use that word replace in your turn and talk. Okay. Our next word this week is sources. Let's find out what that means. Sources are where things come from. Wind and solar energy are two sources we can use. What are your energy sources at home? In this picture, this machine called a turbine, it's called a wind turbine, uses wind and it changes it to energy that people can use in their homes. Wind is just one of the sources we can use to create energy. Can you think of some other sources that you use in your home? Do you use gas, batteries, sunlight? What do you use? Okay, our last word for the week is traditional. And you can see a mom and her daughter, and they're eating a meal together. Let's find out what traditional means. Something traditional is most common or expected. In this picture, Cho and her mother like to eat traditional Japanese foods, such as rice and fish. And you can also see they're using traditional utensils. They're using chopsticks. Now let's look at the picture that represents the word traditional. This girl and her mother are eating traditional foods from their country. What are some traditional foods in your family? Discuss with a partner. Oh, you know what? I saw a picture this weekend, and I saw Maya cooking Latvian food with her mom and her brother because they have ancestors that come from the country Latvia. So they were cooking traditional foods from their culture. That's really cool, isn't it? I hope it turned out good. It looked delicious, Maya. Anyway, all right, that's it for us today. So we're going to take the first half of the end of the year math assessment. We are going to do our spelling pretest plus the 2 worksheets in the Language Arts Pack for spelling. And we are going to do the turn and talk. Hopefully you already did it for vocabulary. I hope you have a happy Monday. I can't wait to see you tomorrow. Bye-bye.